Hello, my name's James Chong. I'm a professor in the Department of Biology at the University of York. Welcome to the System 60 lab, which is part of the Optimizing AD project with Yorkshire Water. One of the critical things for Yorkshire Water is that they know that their customer base is expanding as the population expands. That means there's going to be more material going down the sewer, and there are two ways of dealing with that. One of them is to build more infrastructure, which is really expensive. The other is to try and optimize the process by making it more efficient, which means that you can put more material through the same physical assets. AD is a recycling technology, which means that you can recover resources from waste material. And what goes into sewer is obviously a waste, but within that there is a lot of potential energy. So mainly AD at the moment converts that waste into biogas, which can be used as a drop-in replacement for natural gas. So you can use it for heating, but actually methane is also used as a transport fuel. And you also get a nitrogen-rich fertilizer, which can be used as a resource as well. The systems work in triplicate. Basically, we have what's called a feeder bar at the bottom. We load these syringes with the sludge that we want to feed into the system. The bar moves very slowly up. That pushes the material through a non-return valve here into the bottom of the vessel. The vessel is heated, so we can control the temperature. We can control the rate that we feed at and how frequently we feed at. The system is normally stirred. The material is added. The gas comes out through these pipes. We can monitor the composition of the gas, so we can measure methane and carbon dioxide concentrations. We can also measure the volume of gas being produced as it comes through these tip buckets, and then that's vented out of the room safely. Any extra material that isn't broken down into gas spills over and it's collected in these pots. And that means that we can analyze the sample from the material that we're putting in to the material that's coming out, as well as monitoring what's happening to the microbiology inside the system. The attitude towards sewage sludge is changing, so even within the industry it's now called a bioresource, and that means that potentially we can recycle things and make the whole process more sustainable. The pilot rig is set up to mimic large-scale AD, so we have pumps that recirculate the material inside the vessel. Further up we have another pump that is used to recirculate the feed, so that's the hopper outside. What we don't want is for that material to settle before it gets into the tank, so periodically this basically stirs the tank outside. And then further down we have a pair of feed pumps, so that moves the feed from the hopper outside into the digesters. So we bring the feed in, goes into the digester's stirred occasionally. As the digester produces gas, that comes out and runs into these gas flow meters, so we can measure how much gas is coming out. And then the gas from the flow meters goes through to the analysis panel over there. So we have a gas analyzer. The gas comes in at the bottom, and every 30 minutes measures the composition of the gas, so that we can see how much methane we've got, how much carbon dioxide, hydrogen sulfide and oxygen there is. pH meters, and we have a pair of systems so that we can intervene with one and keep the other, say, as a normal site control, so that we can see what's going on. All the data that we collect, so in terms of temperatures of the vessels, when they're being stirred, how they're being fed, all that kind of stuff goes to the Yorkshire Water standard telemetry system, so all the data from the rig is sent off-site onto Yorkshire Water servers. It's really important that we collaborate between the university and Yorkshire Water, because it gives us access to real-world feedstocks and real-world conditions, and we have a much better idea of what the challenges are that are facing the industry directly. What that means for us is that we can go from lab scale to pilot scale to full scale and have some confidence that what we're doing in the lab is actually relevant to operations on site. So lots of people can potentially benefit from the research that we're doing. Yorkshire Water customers hopefully will ultimately see savings in their bills, because if the company doesn't need to build more infrastructure, there are lower costs associated with this. But anaerobic digestion is used across a much wider community, as well as all the water companies. It's used to dispose of food waste, and it's used to dispose of agricultural residues. So that means local farmers can benefit from this, supermarkets and customers of those companies can benefit. We're also capturing the carbon that otherwise would be lost by going to landfill or some other means of disposal. The results of this project will allow Yorkshire Water to save lots of carbon in terms of not having to build additional infrastructure. If we can put more material through the existing assets by making it more efficient, that means that we recover more gas, which means that less carbon is being wasted, but it also means that there's no carbon involved with building additional digesters.
Behind me you can see the process scale digesters here at Naburn Wastewater Treatment Works. We have a plan to consolidate our anaerobic digestion plants across the region to around 14 centres by 2020. And so region-wide every year we receive around 150,000 tonnes of sludge, and our ultimate objective is to treat as much of this sludge as we can, to convert it into usable energy to help power these sites. So this reduces reliance on purchasing electricity from the national grid, which is very expensive, and it also means that these sites can become self-sufficient. Another one of the objectives we have is to improve the quality of the digestate as much as possible, so the end product from the anaerobic digestion process. We want to make sure that we're diverting this from landfill and want to make sure that we're producing a really quality product for agriculture, where it can be used as a land fertiliser, and that we can actively collaborate with the agricultural sector.
This is the digestate that comes out of the end of the process. It's very good fertiliser that can be used for soil improvement, retain water and help crops grow because it's rich in nitrogen.
We're really excited to be working with the University of York. It's been a long journey to get here, but we're really pleased now that the pilot scheme is active.
This project is leading the way that we can innovate in anaerobic digestion, because we can improve the recovery of resources from the waste material. We can recover biogas, which is a drop-in for natural gas. We can recover fertiliser, but long-term we can actually do more than that. We can start to manipulate the microbiology so that we get higher value products out of this process.